This is the supplemental lecture number 4 for the week 4. And then these are the topics covered. And then you should know what the exponent means, and then you have to know what the scientific notation is, and you need to know how to use the quadratic formula. All right. Before I proceed, I can help you review if you're still struggling with these definitions. So first of all, if you have a given number as a to the m, then right, so the superscript called m is normally called an exponent, which is also called a power. And then if you replace the a and m by a number, for example, you get 2 to the 3. So the power of 3 is telling you that we are multiplying the number 2 by 3 times. So that means you'll get 2 times 2 times 2 equals to 8. So that's why 2 to the 3 equals to 8 instead of 6. So you can't assume that you're multiplying the 2 by 3. That's not how the exponent works. All right. So another example can be something like 2 to the negative 3. All right, so to have that work, you have to, first of all, one way to have that work is to, first of all, separate the rewrite the negative 3 as -1 times 3 on the exponent part, right? And then interestingly, we can see that if you have a number to the -1, then that means we'll have the inverse of the number. What does it mean? That means we're going to turn the number into 1 over the number, like 1 over 2. The number will just ends up staying at a denominator. And then that's how you work on 1 over 2 to the 3. And then again, conceptually, we're multiplying this number 3 times, okay? And then that gives us the final answer, which is 1 over 8. 8 versus 1 over 8. All right. That's a quick review of exponent. Next, we can start the example. Example 1, rewrite this number as a whole number or decimal. So first of all, you'll have the number given. Sometimes when you have a number given in this way and that way, then we have to know that these are the numbers in scientific notation. A factor, 6.32 times the multiplier, which is 10 to the 3. And then 10 to the 3 can be figured out by using the method we had before, right? And then one reminder is that when you have a scientific notation, you only have 1 digit before the decimal point. Okay, so that is the condition needed for the scientific notation. So if you have, for example, if I have the number written as 33.2 times 10 to the 2 instead, then yes, technically the number is correct, but that's not the scientific notation because you have 1, 2 digits before the decimal point, right? You're going to have the points being taken off if you write down the answer like that on WAMAP. So be careful. 1 digit only before a decimal point. All right, and then we can normally solve this by a calculator. We enter the expression in the scientific calculator, then we get 6,320. So if you know the concept, then the problem solving with a calculator allowed will be simple. And then the second one will be 0.0056. All right. One way to figure out without a calculator is to use the point shifting method. And I'll show you how that works. So let's say that if you don't have a calculator, right, and then you want to know the answer. The regular lecture video shows that you can shift the point by a couple of times, and that number of shift depends on the exponent given. So if you have 3 given, that means you're shifting the decimal point 3 times to the right. Okay, and then the decimal point ends up being there to show that, right? That's how you get 6,320. Right. And then the second one will have 5.6. And then the way to shift the point here is that you make up zeros before 5. And then if you have the exponent as -4, that means you're shifting the point to the left by 4 times. That is the rule we follow. And then if the point ends up being there, then you'll have 0.0056, and that's the answer. Right, so that's the trick for you to figure out an answer. All right, and if you're still stuck and if you're uncomfortable with scientific notation, then I can show you why the answers are mathematically correct. So, right. So for the people who are falling behind, this is for you. Right. Just forget about a shift and let's think about the real reason why this works. 10 to the 3 equals to what? Well, 10 to the 3 equals to 10 times 10 times 10, right? According to what I show you right there, we are multiplying the 10 by 3 times, and then we get 1,000. And that's how we get the answer, 6,320. And then if we have 5.6 times 10 to the -4, then we'll have the exponent written in this way, 10 to the 1 times 4, and then guess what? We'll have 5.6 times 1 over 10. We invert the number of 10. And then if we have that 1 over 10 multiplied by 4 times, then we're going to have the answer, which is 10,000, 1 over 10,000. Okay, so that is why we get the answer 0.00056. Right, but remember, we can rewrite the expression in this way all the time. So for example, I can't always work on 10 times 10 times 10 and so on, because if you get something like 10 to the 25, then there's no way for you to write it down forever, right? That's why we have to use the trick to help us easily find the answer. All right, so that is a tip for you. Since we have known why that works, then we can continue with another example. Example 2. Rewrite this number in appropriate scientific notation. All right, now we're doing the opposite. So first of all, we have 0.0318. My method might be different from that in the lecture video, but I want to show you how this works. First of all, if I were you, I will always start counting the point from the spot right before the first digit. So if we're doing the opposite, that means we're counting from in front of 3, and then we move to the left twice to get the real decimal point right there. We're shifting So that means we're shifting the decimal point 2 times to the left to get this answer. So 0.0318 equals to 3.18 times 10 to the negative 2. All right, so that's the scientific notation. A factor, 3.18 times the multiplier. All right, and then you may go, Professor, how about the whole number? We don't have a decimal point for a whole number. Well, we do. Actually, it's hidden right there at the end of the whole number. That's always the case, okay? So whenever you don't see a decimal point on the whole number, keep in mind that it's right there at the right end of the number. So, right, so if we do the opposite, that means we have to count from that starting point 1, 2, 3, 4. So it requires us to shift the point by 4 times before the first digit. Remember that rule. And then eventually we can write down the answer. That equals to 6.97405 times 10 to the positive 4. That's a huge number, and that's why the multiplier is a huge one. Right, so that's how you do the opposite. Right, so when you see the tip for you is that when you see the example with the statement and with the numbers given, that you have to immediately react how to solve it. That's how you reach the mathematical maturity. And that will help for the Math 107 you're taking too. All right, multiply, example 3, multiply or divide the following and express your answer in appropriate notation. Okay, first of all, this can be done by a calculator indeed, but we have to think about how to play with the multipliers. So first of all, I can arrange my expression in this way. I have the factors at the front and then the multipliers at the end. All right, how do we do that? Well, the calculator might not give you a scientific notation as the final answer, but keep in mind that you can apply a rule we learned from the class before, which is called the product rule. Think about it. A to the n times a to the n equals to what? Right. There's a way to combine the exponent. That'll be a to the n plus n, not m times n. Why does it work? Well, we can always prove it with numbers. 10 to the 2 times 10 to the 3, right? That equals to 10 to the 5. It makes sense because 10 to the 2 equals to 100, and then 10 to the 3 equals to 1,000. If you have 100 times 1,000, then you'll get 100,000. And that's exactly 10 to the 5. So that proof is always the one you can try, and then that's why we can make the wrong assumption. So if we believe that the exponents are are being multiplied, and it gives you 6, then you're already making a wrong assumption in the language of math. You got to be careful. And then there's always a reason why we have the rule defined in such a way. And we can always prove that by using the real numbers. All right, so the calculator will give you, back to the question, the calculator will give you the first part, which is called 8.85. I'm not sure why I can't draw anymore, so let me try this again. All right, 8.85 times 10 to the 58. 8 plus 50 equals to 10 equals to 58. So that's the answer. So that portion matches the rule we have there. Make sure you understand why this works. Okay, next we have a huge fraction. All right, so how do we deal with it? So first of all, apply the product rule first. When you have multiple scientific notations in one line. So we have 1.2 times 4.2, and then we have 10 to the 50 times 10 to the negative 12. Okay, so let's take a look. 1.2 times 4.2 can be done by the calculator, and then the calculator is allowed. And then we got 5.04 on the denominator. And then if we think about the rule, then we will have 10 to the 50 plus, we have 50 plus the negative 12, which gives you 38. Stuck? I'll show you. 50 plus negative 2. These two numbers are additive, and that's how you get 38. All right. Then we have to think about a quotient. Another rule tells us that if we have a to the m over a to the n, then what do we get? That will give us a to the m minus n. And again, this is mathematically correct. And you can always prove it by plugging in the numbers. And then we're going to apply that on the current fraction we have right there. First of all, we have 9.36 times 5.04, and then we can work on the multiplier in this way. That would be 10 to the negative 75 minus 38. Well, can we do that? Yes, we can. Why not? All right, so 9.36 divided by 5.04. The calculator shows that we got 1.86. Well, if you want to plug everything into the scientific calculator, if you're able to, then that's fine. But I still have to teach you how the rules work. So negative 75 minus 38 equals to negative 113. So that is the final answer. And then I'll tell you what, those two rules we recall works on the equation 4 as well. We have that huge fraction. And then, yes, we can keep in mind that, right, if we have several terms, we have several parts being multiplied, then yes, we can separate the fraction in this way. So we can separate the like terms. So we got 10 over 25 and times x over x to the 15 over x to the 7 times y to the 17 over y to the 5. Okay, so the quotient rule shows that, first of all, we have 0.4 on the first part, and then we have the x terms, which gives us 15 minus 7, which equals to 8. And then the y term have the exponent as 17.5, which is 12. And that's the final answer. And then the scientific notation is not required on this question, so it is okay to leave the answer like that. So when you have symbols with the exponents on the fraction, then that's how you deal with it. And then this is how you simplify the fraction. All right, example 5, let's keep practicing. If you have something tricky like that, well, keep in mind that, right, the like terms can be separated j to the negative 3 times f to the negative 4 over j to the negative 9 times f to the negative 2. All right, so first of all, work on the j terms and then work on the f terms separately. Once we got a concept, then the progress will be smooth from now on. All right, quotient rule tells us that j, this is the part I want to go slower. J equals, we have the power of j, which is negative 3 plus negative 3 minus negative 9. Okay, so remember, we have a negative number minus a negative number. And then for the f, we have negative exponent as negative 4 minus negative 2. Quotient rule. And then what is the answer? Negative 3 minus negative 9. Think about it. What would that be? Positive 6. Negative 4 minus negative 2 equals to negative 2. Answer. The simplified term at the end. And then gotta be careful. We're not done yet because we have to write the answer without negative exponents. And then this is a red flag because, ooh, that negative 2 is the negative exponent. Now you can see the difference between example 4 and 5. Example 5 has one more condition you need to meet. We have to turn the negative 2 into positive 2. And how does it work? Well, keep in mind that if you have something to the negative exponent, then that equals to 1 over the number times the positive exponent, right? So that interestingly equals to 1 over f to the 2, because 1 to the 2 equals to 1. Right, so that means the second part gives us 1 over f to the 2. So the answer will be j to the 6 over f to the 2. That is the answer needed. So sometimes you got to read the question carefully and see what you're solving. Next, example 6, simplify completely. All right. So if you have a chunk of fraction, you have a huge fraction to a certain exponent, then we can recall that the exponent can be distributed on each part. So how does it work? Right. Negative 2 will have the power of negative 2 applied. And then p to the 4 will have the power of the negative 2 applied. And then p to the 3 will have the negative 2 being multiplied. And then y to the 3 will also have the negative 2 being applied. Because another rule we have learned is that if you have a to the m to the n, then that's when you multiply the m and n together. So for the same power applied to every single part on that expression, we can distribute that power. And then what do we get? Right, negative 2 to the negative 2, that will give us negative 2 to the 2 times negative 1. Right, I will go slow on this one to show you what the value is on the upper left portion. But we can work on the others at the same time. 4p to the 4 times negative 2 gives you p to the negative 8. And for the denominator, the same rule tells us that we have p to the negative 6 times y to the negative 6, okay? All right, so first of all, negative 2 to the 2 equals to positive 4. Because if you multiply negative 2 twice, then you'll get positive 4. And 4 to the negative 1, again, gives you 1 over 4. So that first value is indeed 1 over 4. And then, right, we're not simplifying this expression yet. So we've got to think about the next step. The like term is the p terms for this time. All right. So let me go slow and then handle the like terms. We have p to the negative 8 over p to the negative 6. Then that will give us p to the negative 8 minus negative 6. Okay, and then if you have the expression as y to the negative 6, we can deal with that as well. And then let's see, the p term will ends up having the exponent as negative 2. And then how about the first part? Let me show you. 1 over 4 over y to the negative 6. That's the ugly one. But that's doable. That will be 1 over 4 over 1 over y to the positive 6. And then p to the 2, let's make it stay there. Okay, we have a fraction over fraction, guys. Fraction over fraction, well, that's the fraction over fraction part is doable. So if we have that, then that means we have 1 over 4 times y to the positive 6. Because if you get rid of the main fraction at the denominator right there, then you just have to flip the y. You have to invert the y again to get y to the 6. Right. That's how the trick works. So the last term is still p to the negative 2. All right, so that is the final answer. We simplified everything completely right now. And then if you want to have another version, then you can also write it as 1 over 4 times y to the 6 over p to the square. That also works. That's another version of the answer. All right, so that is how the simplification works on example 6. All right, now we are approaching example 7. Compute the discriminant of that equation. How many real solutions does the equation have? All right, so when you see this type of question, then you'll tell that, hey, now we are dealing with the quadratic formula. First of all, it's important to decide the coefficients for that quadratic equation. The term, the factor before x squared term, that's called a. And the factor before the x term is called b. And the factor before, with no x, then that would be c, which is negative 2. And then if we recall the quadratic formula, then we can see that the way to solve x, that x equals to negative b plus minus b squared minus 4ac over 2a. So this is called a quadratic formula, which is derivable somehow, but the focus is not to derive it right here. We focus on the concept instead. And then the term right here is called the discriminant. Now, what does discriminant mean? Again, well, the discriminant is the numerical portion that helps you determine the two roots of the answer. So think about it. We have one number plus minus another number, right? So the second term on the numerator will helps you determine how many solutions we have at the end. So in this question, we're not actually solving for x. We're computing the discriminant only. So that means we only have to work on the b squared minus 4ac portion. And then let's review it together. All right. I do want to highlight the right portion again, right? When we have the discriminant, that actually doesn't include the square root sign. So I'm talking about just that portion inside, right? That's the definition. All right, then let's go over this portion. Again, b equals to 9. We found that right there. So we have 9 squared minus 4 times a, which is 8, and then c equals to negative 2. So let's calculate the number first. We have 9 squared minus 4 times 8 times negative 2. So if I want to do it without a calculator, then I'll have 81 minus negative what? Think about it. That will be 64, right? And then the answer is positive. So we got the discriminant, which is 145. So if the discriminant is positive, that means we have two solutions. Right. So that is a rule. Because if you have a positive number, then it works with the square root. That means that then means we are able to get the answer with positive root or negative root, right? And then there are other conditions. The discriminant can be 0 or negative. Then that will give us 1 solutions and then no solutions in order, right? So again, the reasons should be covered in the lecture video, so make sure you watch them. All right, now we'll practice the last example and then see how the discriminant works. All right, solve the following equation. This is indeed when we apply the quadratic formula. Let's check out the coefficient. A before the k squared term. So we are not having the x terms, but the k terms. But don't be fooled by the symbols. The method is the same. A is positive 4 before the k squared term. So we have a equals to 4. And then we have minus 3k. So that means the b term will be negative 3. And then the C term will be -2 instead. All right. This is the way we set up the quadratic formula. The variable can be solved by -b plus minus b squared. So inside the square root portion, we have b squared minus 4ac over 2a. All right, so the procedure is that first of all, you get all of the coefficients identified, and then you plug the coefficients into the equation. Now, -b is -3, so we plug that in, and then we plug in another b inside the square root. So we have -3 squared minus 4 times -2. Okay, and then we have the a and a denominator, 2a, which is 2 times 4. So negative signs canceled, and then we will have +3 plus minus 9, and then the second part should be 4 times 4 times -2, which gives you -16. And then the denominator will turn into 8. All right, so looks like the discriminant is positive 25. And then square root of 25 equals to what? That would be 5, right? So we ends up having 3 plus minus 5 over 8. Okay, so this is the part for us to think about the meaning of the plus minus signs. So if you have the plus minus signs, that means they're, and if your discriminant is positive, then that means you have 2 answers, 2 solutions. So the first one would be 3 plus 5 over 8, which equals to 1. That's the first solution. And then the second solution would be 3 minus 5 over 8. So you have 2 solutions solved by 2 signs separately. So that would be -1 over 4. So what is the meaning of having 2 solutions? Well, think about it. Right. It means there are 2 values you can plug in into the original equation. So if we have a quadratic, if we have that equation, original equation, then we can plug in 1 into the equation. Right. Let me recover my drawing tool again. We can plug in 1 back to the equation, and then the equation will be satisfied. And then we can also plug -1 over 4 into the equation. And then I guarantee you that it will work with the second number as well. So that is the meaning of having 2 solutions if the condition is met. Right, so in case you didn't know the reason we're having multiple solutions in the case, I just explained it and hope that helps. All right, I wish the supplemental lecture video helps. And then make sure you practice more problems and then finish the homework and the quiz for the coming week. And then I'll see you next time.